Today I'm going to do my best impression of the Rough Riders' first lady. I'm going to blow your mind. Her name was Eve. She's from Philadelphia. And here's how I'm going to do it. Remember the last two sections where we had that awful limit formula? The limit as h approaches 0 of f of x plus h minus f of x over h. And every single time we were asked to find the derivative, we had to find out what f of x plus h was, plug it all in, hope that things cross out, hope that we can factor out an h, cross it out, plug stuff in again. It was a nightmare. Now I'm going to give you all the shortcuts, which means everything that we learned up to this point in this chapter, we didn't really have to learn. But I taught it to you anyway because it's good for you and you're welcome. And sometimes you have to slay the dragon before you can enjoy the feast. It's biblical. Look it up. I think it's Revelation. If I wanted to find this guy, according to what I know from the last two sections, I would have to find f of x plus h, which means I would have to replace that guy with x plus h and then FOIL it out 4 times and then do it again and FOIL it out 3 times and then do it again and FOIL it out and then do it again and distribute and have this huge mess and combine like terms, and then I'd have to plug in regular f of x and subtract that whole thing and hope I don't make a mistake. Well, now I'm here to tell you that I could just look at this guy and know that that's going to become 12x to the third plus 30x squared minus 2x minus 13. How the heck did I do that? How the heck did I do that and use that limit formula at the same time? Well, I didn't, because there's a shortcut. Many shortcuts, actually. 2 primary ones. The first shortcut is if you take the derivative of a regular constant, you get 0. And that's because we learned in a previous section that if you take the derivative of a polynomial, it drops a degree. So if you have a constant which already has a degree of 0, and you try to take a derivative of a polynomial with a degree of 0, you drop a degree which dips into the negative, and there's no such thing as negative polynomial. So it just goes away. That's the first shortcut. So this guy just goes away. That guy right there. Well, how did I do these other ones? Let's move to my document camera and find out. Here's the second rule, and this second rule is going to be the rule that burns your biscuit to bits. The old triple B. Normally, if I had something like x to the third and I needed to find the derivative of x to the third, I would have to find out what f of x plus h is, and then I'd have to do x plus h to the third and get this whole nightmarish situation. Not anymore. If you're taking the derivative of something like x to the third, or like I have there, or x to the 13th or whatever, what you do is you take the number. So you have x to the nth. What you do is you take the exponent. You bring it out front. So now you have n in front of x, and then you remove 1 from the exponent. Take the exponent, bring it out front so it's now a coefficient, and then subtract 1 from the exponent. So you take the 3, you bring it out front, and you subtract 1 from 3, and so our answer is 3x squared. So in previous lessons, that problem would have taken about 7 minutes. Now it takes about 7 seconds. This problem would have taken about 7 hours. But now what I do is I say g prime of x equals, bring the 13 out front, keep x, subtract 1 from 13, so 13x 12 to the 12th. And as time goes on, we're just going to skip this step right here. Because why do I have to do 13 minus 1? Well, I don't. Now here you might be saying, I got you there, sir. You can't do it. Wrong again. Did you know that if you have an x in the denominator of a fraction, you take that exponent, make it negative, and bring it up top. So this is the same thing as saying y equals x to the negative first power. And so y prime would equal, bring out the exponent, negative 1 x to the negative first power, take away 1. So that becomes negative 1 times x, which is negative x, to the negative second. And I hate the way that looks. So negative 1 over x squared. Right now you're steaming, thinking, why didn't he teach us that before? I don't know. Rule 3. If I have a coefficient, so take these types of problems here, take this guy and throw a 5 in front of it. How does that change things? Well, it doesn't. If you have something like 3, what did I have before? X to the third. And I'm asking you to find the derivative, just pull 3 out and take the derivative of x to the third. Which, as we know, becomes, bring the 3 out, subtract 1 from 3, that. So you might be saying, oh, well, okay. Now that we know that rule, can't we just say when you bring the 3 out front, you multiply to the coefficient that's already there? Okay. Yeah, let's do it. So bring the 4 out and multiply it to the coefficient that's already there. So that becomes 8. Subtract 1. Just like the last problem or the second to last problem, we'll rewrite this as negative 3x to the negative fourth. Okay. So the derivative of that, f prime of x, is negative 4 times negative 3, which becomes positive 12, x to the negative 4 minus 1, which becomes 12, x to the negative 5. And I hate the way that looks. So 12 over x to the fifth. What rule 4 is saying is if I have a polynomial, right? So I have 2 terms going on here. If I take the derivative of a bunch of terms, whether it's 2 terms or more, I just take the derivative of each one and do whatever the sign says I do. So in this case, I'd take the derivative of u plus the derivative of u. That's it. So before, we would have had to find out h plus or x plus h cubed and then x plus h. And then we'd have to make sure we distribute the negative when we do minus f of x and all this stuff. But not anymore. F prime of x is x cubed, which means bring the 3 out front, subtract 1 from cubed, boom, plus 2x means bring, well, there's no exponent. It's just an invisible 1. So bring the times 1 out front and subtract 1 from invisible 1, and you get nothing. So I don't know if I necessarily said this rule, but the derivative of x is 1. So that's going to make life a lot easier. Sorry about the sloppy writing. The derivative of x is 1. So the derivative of 2x is 2. The derivative of 8x is 8. The derivative of a billion x is a billion. Now, they can't always be that easy. Not all of them. Some of them, but not all. I like the way that this looks. I like the way this looks. I know what the square root of 4 is. Oh, why did I put an equals? I know what the square root of 4 is. It's 2. Oh, the square root of x. Oh, if only I can rewrite that as an exponent. I can! X to the 1/2. bring the 11 out front. Oh, so that would make y prime equals, bring the 11 out front, multiply that to the negative 2, so negative 11, x to the 11 minus negative 22. Oh, man. I brought the 11 out, so negative 2 times 11, negative 22, x, subtract 1 from 11 to the 10th power. Bring the 1/2 out front and multiply it to 2. Half of 2 is 1. X. Take away 1 from a half and you get negative a half. I hate the way that looks, especially since I don't know how to multiply 11 and negative 2. So I have negative 22, the negative Taylor Swift special, plus, I don't need that 1 there, but I will put the negative 1/2, I will move x to the denominator and call it that. I still hate the way that looks. Why? I just don't like fraction exponents. They look sloppy. So last but not least, negative 22, Taylor Swift special, x to the 10th plus 1 over root x. Now I'm happy. This was the problem at the very beginning of the lesson that I was able to just quickly spout out the answer to. Yesterday, or the previous lesson, if we were to attempt this, it would take us probably a solid half an hour, and it would just be miserable. It would be misery. So we're not going to do it. I'm going to do it this way. Y prime equals 12 x to the third plus 30x squared minus 2x minus 13, and you go away. F prime of x is going to be, and I'm just going to write this out because fractions are rough for certain people, 3 times 2/3 x to the second. Remove 1 from 3, gets squared. I should have rewritten this out as negative 3x to the 1/2. So what I'm going to do is I'm going to bring out negative 3 times 1/2 x. And if I subtract 1 from a half, I already know what I get, negative a half. Two x squared minus 3/2 times 1 over x to the 1/2. That equals 2x squared minus 3 times 1 is 3. 2 times x to the 1/2 is 2 root x. Remember, a horizontal slope, okay, is 0. What it's asking us here is what points does the graph y equals blah, 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 blah have a horizontal tangent line? What does that mean? Well, this is asking, when is the slope of the tangent line? Oh, slope of the tangent line, that's the derivative. So when is y prime equal to 0? If it has a horizontal tangent line, that means the slope is 0. So when is y prime, the slope of the tangent line, equal to 0? So let's find y prime. Y prime equals 3 times a third is just 1, x squared, minus 2 times a half is just 1. 2 minus 1 is x to the first, minus, it's just an x, so 6. Now I have to find out when this guy is equal to 0. So let's turn y prime into 0. And we're going to use the zero product property and figure out the two numbers that add up to negative 1 and multiply out to negative 6. And of course, algebra 2 rings a bell. And that's going to be our guy right there. Boom, boom. So what points does the graph of that guy have horizontal tangent lines? Well, it has horizontal tangent lines at x equals 3, because if I plug in 3, I get 0, and the whole thing equals 0. And at -2, because if I plug in -2, this guy becomes 0, and that turns that into 0, and I get 0. Boom. 2 apostrophes. The heck? I'll tell you the heck. 2 apostrophes just means take the derivative twice. And when I throw an of 3 in there, that means when you're done taking the derivative, plug in 3. Now, it's very important that we understand with these problems, you take derivative first, derivative, then substitute in the number. Why not go in the reverse? Because if I were to plug in 3 into that guy, I would get a number. Okay? And if I took the derivative of a number, I get 0, and I get 0. So it's kind of a waste of time. Now, here's an issue. I have stuff going on up here and stuff going on down there. We've never seen a problem like that before. I mean, the rules that I gave you, does that mean I take the derivative of that and the derivative of that and the derivative of that? Nope. What we're going to do is, reading this out is just saying 3x to the fourth minus 2x squared, all of that divided by x, which will turn y into, let me see, 3x to the fourth divided by x is 3x cubed, because I subtract exponents, minus 2x squared divided by x is going to be 2x, because I do 2 minus 1 exponent. So that's y. So y single prime, the first derivative, is going to be 3 times 3, which is 9x squared, because I subtract 1 from cube, minus 2. Y double prime is going to be 2 times 9, which is 18x, minus, well, you disappear. So y double prime of 3 is going to be 18 times 3, which is 54. Y triple prime is 18x, the derivative of 18x. Oh, that's just an x, which means the x goes away. Y triple prime of -1 means I plug in -1 for every x. There is no x. So that makes life easy. No x sounds like my high school dating history, because I didn't have. Last problem of the day. If y equals 2x to the 10th, and I need to find the fifth derivative, not bad. The first derivative is going to bring that 10 out front, 120 x to the 9th. Oh boy, I'm going to want a calculator for this. Bring the 9 out. Y double prime is bring the 9 out front, so 120. Oh no, my batteries are dead. Siri, lead the way. 9 times 120.
It's 1080.
Ooh, 1080, my favorite N64 snowboarding game. Y triple prime is going to be 8 times 1080. 8 times 1080.
It's 95,040.
Oops, I accidentally said 88 times 1080. 8 times 1080.
It's 8,640.
Now, fun fact, once we get beyond the triple prime, we show the fourth derivative by putting it in parentheses like so. 8,640 times 7.
It's 60,480.
So the fifth derivative, 60,480 times 6.
The answer is 362,880.
You feel that in your lungs? That's a breath of fresh air. So much more convenient than what we did in the last two sections. Now, what we're going to do in the next couple sections is more rules that we're going to have to learn for when we multiply and divide functions and when we have composite functions. Okay? Stay tuned. Bye.